All right, thank you for coming to our talk today on security practices for customizing multiple environments. We're really excited to talk to you guys about how customizations across your environment really play a very critical role in the security, reliability, and resiliency of your environments and operating those environments at scale. My name is Eric Westfall. I'm a principal technologist for cloud governance and security. And I'm here today with Sid, who is our product and user experience lead for AWS Control Services. And we'll be batting back and forth as we go. As we start this talk, I would really like to always start with the why. And when we talk about why do we need to customize our environments, why do we need to worry about this in the context of security, it's really foundational to think about this from the concept of paved roads. And a paved road approach really involves creating those secure, repeatable patterns to apply consistency across your environment. If you don't have consistency and you don't have repeatable patterns, you can wind up in a situation where you have drift across your environment, and it becomes very untenable as you scale out from a few accounts to hundreds of accounts to thousands of accounts. It becomes a very troublesome problem. And if we think about paved roads, it's really about laying that foundation, laying a road for your developers and for your people on your teams to really create products, to innovate at speed, using the roads that you lay for them, using that secure foundation, using those repeatable patterns that you lay out for them. And if we think about this, to dive a little bit deeper into that term of customizations and customizing your AWS accounts, I think the critical thing to remember here is that no matter whether you have 3 accounts and you're starting off early in your journey, or you've extended way into your journey into the cloud and you have thousands of accounts and you're operating across multiple regions, you will customize your accounts. The only question is how are you going to do it, right? You end up in environments almost always where you have a multi-account environment that's dependent on shared service accounts, networking, think transit gateways or centralized network VPCs where we might do traffic inspection or apply firewall rules. We might have CI/CD pipelines or code analysis checkers, artifact repositories, things that other accounts are going to depend on and need in order to do their work, right? So how do people customize their accounts? Well, you might use an orchestration or customization framework like we're going to talk about today. You can create ad hoc scripts or in-house tooling. And some people early in their journey start off manually doing these things. Maybe they're following a runbook, a wiki page, or a document, or they're sort of just, we always do X, Y, and Z, and that works for us now. But the challenges are always, as we talk about, right? When we look at cross-account resources, cross-region resources, third-party tools, integrations, dependencies between those resources, as you scale from a few accounts to thousands, this becomes a very challenging problem to manage if you're not doing it in a very deliberate and automated fashion, right? And so today we're going to talk to you guys about what it is to set up a multi-account environment from a secure, paved road approach. We're going to talk about the different customization options. And what we want to do is when you leave this session, we want you to understand why this is important, why it's on the critical path for security and reliability, what options are available to you from AWS, whether those are in Control Tower or other different services that we have. We're going to do a feature announcement and a demo, live demo, hopefully, of that new feature announcement. And we really want you to leave this session understanding what those options are, and then how to evaluate them and select the things that are right for you, right? And so before we get too into the weeds, I'm going to hand it over to Sid to talk to you guys a little about Control Tower, the role it plays in the multi-account environment and customization story. All right? Thanks, Sid.
Thank you, Eric, and welcome to our session. Super excited to be here to share this with you. Let's start with a quick show of hands. Raise your left hand, please, if you have heard about AWS Control Tower. Awesome, most of you. And now raise your right hand if you use Control Tower today. Great, about half. Awesome. Well, let me just do a quick intro of Control Tower for those of you who are new. For those of you who use it, hopefully this will be familiar to you, but you may see a couple of things that you don't know about yet. We think of AWS Control Tower as really the easiest way to set up a multi-account environment in AWS. There are other ways, like AWS organizations, that you can use, but Control Tower is really the easiest way. And we say that because Control Tower orchestrates multiple services on your behalf and has the right set of opinionated defaults that represent AWS best practices. Let's dive one layer deeper and see what this means. So what do you get with Control Tower? You get 4 key things. Number 1, you get a landing zone. Think of a landing zone as your home in AWS or in Control Tower. It has your organization with the OUs that you have set up. It has your options for which regions you want to govern, your encryption settings, and so on. So your landing zone is really your home when you come to Control Tower. As AWS best practices evolve, we keep evolving the landing zone version. So Control Tower takes the burden of keeping up with the latest guidance, and you don't have to track that. The second thing you get with Control Tower is managed controls. So Control Tower works across multiple services like Security Hub, Config, SCPs, and others to aggregate controls in all of your accounts that are under governance. With our latest launches, Control Tower now has 400 managed controls for you to select from. And those controls are shown in a way that correspond to popular compliance frameworks, popular control objectives, and services in AWS that are governed by those controls. So you can quickly pick and select the controls that make sense for your business. The third thing you get with Control Tower, which we'll spend most of the time on today, is the account factory. It's a way to create new AWS accounts in an automated fashion that have all the chosen controls and settings pre-built. That's where we'll spend most of the time. And then the last but not least, you get a centralized identity solution. So Control Tower integrates with Identity Center as well as other third-party identity providers, so you can define your users and permission sets and federate them right into Control Tower. The best part is that this is not a one-time set and forget operation. With Control Tower, as your business scales, as your number of accounts grow, or as your compliance needs change, you can keep evolving each of these 4 parts and keep on top of managing your multi-account environment. So this is really the benefit of Control Tower. Now, for those of you who don't yet use Control Tower, let me just quickly go into what a landing zone really is and what it contains. So you start off with your management account, which is where most of the administration happens. For those of us who are cloud admins or platform architects, this is where you'll spend a lot of your time. It has your organization. It has the OUs. Now, by default, Control Tower starts with 2 OUs, a security and a sandbox OU. But you can define any number of organization units that you need for your business use case. And then there is the Identity Center configuration that I spoke about before. In the security OU, there are 2 key shared accounts, the log archive and the audit account. The log archive is a shared account that basically gets all of the config and CloudTrail logs from your governed accounts and puts them into a single S3 bucket, which is great for your security or compliance teams to see all of that information in one place. And the audit account is again similar. It's for security and compliance teams to have read-write access to the other accounts to get notifications or run any remediation. In the sandbox OU or in any of the OUs you define is where your provisioned accounts go. So when you use Account Factory and you create new accounts, or you can also migrate existing accounts from the rest of your organization into Control Tower, they would then fit into one of the organizational units that you have defined. So this orange box is where we'll spend most of the time today to think about how do you further customize these accounts that you're provisioning. So as AWS, we have the benefit and privilege of working across thousands of customers, and we learn from them every single day in terms of the wide variety of use cases, the scale at which they operate, and their technology preferences. And as you think through these 3 axes, there's a wide variety. For example, Company A, I've just chosen some few examples. Company A you can think of as any classic small or medium business who is just starting out on AWS, has a few handful of accounts, and wants to pre-provision those accounts with some basic services like a VPC or a well-configured SageMaker Studio for their ML teams and so on. Company B is a global enterprise that has multiple regions they operate in and hundreds of accounts. They also have complex customization needs such as IAM roles, config rules, maybe third-party partner solutions, and some interdependencies between them, right? You may have IAM roles that then have access to specific tools and so on. And last is Company C, who is similar to B in the terms of being global in scale, but they prefer Terraform as their IAC tool of choice. Quick show of hands, how many of you use Terraform today? Yep, about half of you. So that's the feedback we also get in customers where they're choosing between CloudFormation and Terraform. So now to meet this wide variety of use cases, we have 3 different frameworks we'll talk about today. Customization for Control Tower, or CfCT, Account Factory for Terraform, which is AFT, and then Account Factory customization. Now, most of the times when I tell customers about these 3 frameworks, the first question I get is, why are there 3 frameworks? Why not just have one? I had the same question when I first started with Control Tower. What helped me understand is looking at it in the arc of the timeline and the evolution in this space. So let me walk you through that a little bit. Let's flash back to Inforce 2019 when we first launched Control Tower. This was the first time you could use a managed service to automatically provision accounts that were pre-built with the customization options or the controls that you had. But customers had no way to customize them further to add their third-party solutions or their shared services. So we as AWS quickly responded with a solution called CfCT. And this uses CloudFormation StackSets to customize your accounts. This was great, but for those of you who use Terraform, we got the same feedback of, hey, I'm using Terraform and there's no solution for me. That's when AFT was born, and it was another AWS solution that we provided as a Terraform module that you can now use to create and customize accounts using Terraform. Now, when both of these were in place, both CloudFormation and Terraform customers had something, but there was a significant burden on you guys, the customers, to own the pipelines, build the pipelines, and maintain them over time. And that's the feedback we got, saying we really want a managed service feature that takes this burden away from all of the customers, which is why in reInvent 2022, we launched AFC. AFC is a feature of Control Tower and is fully integrated into it. So the burden gets transferred more to AWS to do it once for all of our customers. So hopefully this evolution makes a little more sense of why there are 3 frameworks, but we'll go into much more detail of what are the commonalities and differences between each of these frameworks. So I'll have Eric back, and he'll talk to you about CfCT and AFT.
Thanks, Sid. So, if I don't mess up the laptop there. Oops. So, as Sid mentioned, if we look at commonalities across all the different frameworks, we've got CfCT, AFT, AFC. What we're really trying to accomplish, right, is to define some sort of desired end-state configuration that's consistent across our environments. The best way to do that is to use declarative configuration management, right? So whether that's HashiCorp Terraform or CloudFormation or Pulumi or whatever tool you use, right? We want to really get into the state of, again, to define declarative configuration management, right? The difference between imperative is how to get where we're going explicitly versus what we want it to look like, and you figure out how to get there, right? So again, the beauty here is simplicity. It's more readable, and we can define an environment end state that's easily defined, easily readable. We can check it with policy, and we can enforce consistency across our environment. And really, as we look at this, going back to what we were talking about before, consistent, repeatable environments, right, through customization workflows. And we'll get into the weeds here in a little bit about how we think about baseline configuration, which might be very simple environmental changes that you want to apply versus more complex use cases that require orchestration and things like that. But at the end of the day, if you think back to what we were talking about before in the early stages of why, scaling from a handful of accounts, you have that temptation to sort of be manual about things, right? It's easy to say, well, I only have 5 accounts, and all I need to do is create an S3 bucket for my security team. I'm just going to go in there, I'm going to do it by hand, it'll be fine, and then we'll move on, right? But at the end of the day, that effort it takes to define that manually versus in configuration management might seem daunting at first to sort of spend the time defining that in CloudFormation or defining a Terraform module to set all this up. But that pays dividends as you continue to scale from those handful of accounts to hundreds, thousands of accounts. We've seen customers with numbers as high as 14,000 AWS accounts operating across multiple regions. No one can do manual configurations and hope to accomplish that in a consistent way, right? And so this is what we think of when we look at our own scale, our customer scale. We need to have a repeatable manner to do that, right? I want to lay a little foundation of, as we start to get into the more complex frameworks, one of the underlying technologies and principles that's often used, especially in CfCT and at AFC, is CloudFormation StackSets. And if we think about CloudFormation StackSets, really the benefit here is extending the capabilities of CloudFormation to multiple accounts, multiple regions, right? And so the inevitable question is, why not just use StackSets, right? And we'll get into that. But there's a lot of great stuff here in StackSets that allow us to orchestrate these environmental changes. One of those is this idea that, let's say in our management account for Control Tower, we define a stack set that is going to set up some IAM roles and integration for a third-party SaaS tool. Let's say we're using Wiz, or we're setting up some sort of other scanning tool or something like that, and we need to define some access into those accounts and some resource configuration so that those services can work. One of the great things is we can set up a stack set in here, and with integration, trusted access into AWS organizations, as well as service managed permission models that CloudFormation StackSets has, we can do tight integration with organizations to target these stack set deployments to individual accounts, groups of accounts, OUs, or the entire organization, right? And so this allows us to dynamically define these provisioning steps without having to know in advance which account IDs to target, because as accounts come and go from OUs, or they join your organization or leave your organization, StackSets will automatically provision these stacks in those accounts, right? And when we talk about service managed permission models, right, CloudFormation StackSets can operate in a managed model, or you can control it yourself. But in the service managed model, it uses service-linked roles. SLRs are essentially a role that's tied directly to an AWS service, managed and created by an AWS service. You can see it in your account, you can't modify it, right? And in this example, we're seeing the SLR get created by CloudFormation StackSets in the accounts we're targeting, let's say a workload account B, and you'll see it creates a StackSets org member SLR in there. And when we actually go to provision the CloudFormation stack to apply those changes to our accounts, it will create a just-in-time execution role, right, which is scoped down to just that particular stack, and it's independent of any other stacks deployed in that account. That role is assumed and then used to create the stack and deploy the stack in the target account. CloudFormation then creates a local stack from the stack set template and executes that, and here we have our customizations applied to our local account, whether that's a VPC or setting up some flow logs, or like we mentioned, maybe some IAM roles to allow a third-party tool. This is a very great way, and a lot of our customization and capabilities are predicated on StackSets technology. Taking it a little further, StackSets can also integrate into other capabilities, like how do we put CloudFormation StackSets into our account lifecycle so that anytime a new account is created or changes are made, we don't have to sort of wait around or sort of wait for somebody to, on a periodic basis, check. We can immediately trigger and make sure that we're doing the customizations we need in a quick and efficient manner. lifecycle events come into play here. So if we look at AWS Control Tower, a lifecycle event, in this case, its purpose is really to mark the completion of certain AWS Control Tower actions that might change the state of your resources. So again, creating a new account in Control Tower is an event that would certainly change a resource. So in this case, if we go and we create a new account and we look at Control Tower in the concept of an orchestration layer, it's orchestrating actions across a number of different services on your behalf, right? It's not just Control Tower creating an account, it's calling out to AWS organizations, it's calling out to IAM, it's calling out to all sorts of services underneath to accomplish the task you've told it to do. It will manage that state and go through each of those steps and transitions of state, monitor them for success, and at the time when we've said all of the steps necessary to sort of create that account, enroll it into Control Tower, get it managed, and apply some controls and baselines to it. Once all that's done and successful, we'll report back that that is successful, and we'll emit an event on the bus to EventBridge saying, create managed account lifecycle, state complete, success, right? Or failed if something happened in the intermediary steps to fail, right? So we can set up a rule to catch that event. We can have a Lambda function that knows how to process that lifecycle event, and then maybe take some actions on our behalf to call CloudFormation StackSets, and maybe create a new stack set or trigger a new stack set instance. You could do this without using service managed permissions if that's what you wanted to do. Or integrate it as before with service managed permissions through organizations, right? But in the end, then we can trigger our customizations through that stack addition, right? We've got a new account, put it on the stack, get that trigger going, and again, we can start to provision our resources like roles or VPCs in that account. We can also just trigger those customizations directly through a Lambda function if that's what you want. Again, that's going back into sort of imperative versus declarative, but sometimes there's a use case for that, and it just depends on what you're accomplishing, right? This is a very powerful construct between CloudFormation StackSets and lifecycle events that really allow you to accomplish a lot without getting into the weeds too much. But there are a lot of moving parts. So what are some signs you might need an orchestration service to begin with, right? Why not just do all that and be done with it? That's certainly a tenable option, but when you find yourself needing to apply a lot of the customizations to an account or an environment, you might find that you need to make decisions about which customizations to apply based on some environmental factors. Is this account a prod account? Is it a non-prod account? Is the data policy, does it control customer data that's confidential or potentially subject to regulatory compliance, right? Based on those factors, I might apply a different baseline or a customization to it. I might need to enforce a particular strict order of operations or a sequence, right? I might have strict dependencies that say I have to have these prerequisite resources before this customization can be applied. You might have workflow patterns that look like some manual human approval is required before you proceed with this particularly dangerous customization or something. I might need to run them in parallel or make some branching logic that says if something fails, then take a different action than you would if it succeeded, right? All of these things get complex, and this is a very good sign that you need to have an orchestration service on top of what we just talked about, right? And so with that, I want to sort of get into the CfCT part, or the customizations for Control Tower, right? And really, this is a pipeline-based approach that can handle both your CloudFormation templates and service control policies through organizations. So this is a pipeline that's going to allow you to manage not just CloudFormation templates, but again, some of those preventive controls that might be important as compensating controls for customizations you're applying. Let's say you put something in an account, you need to protect it against modification or deletion. This is a good way to tie your template and an SCP to protect the resources that it creates at the same time, right? Again, we can target individual accounts or OUs. And one of the great things here, right, is this close integration with lifecycle events and Control Tower with CfCT. Again, as we talked about, we're looking for these lifecycle events, and we're immediately triggering pipeline operations by pushing it into a first in, first out SQS queue. We have a managed Lambda handler that comes in that pipeline to handle that processing for you and decide what the right action is to take. And this is where we get into a sort of a GitOps or pipeline-based approach, right? This is code pipeline here, but we can also use other version control repository sources like GitHub, for example, to hold those artifacts like our CloudFormation templates or SCP manifest, those types of things, right? And use a code build operation or something right, like that, right, to apply checks. This is a very powerful part of using a framework that's pipeline-based for these types of things, because this is where we can do things like linting. We can apply static analysis and checkers. We might actually apply policies like CFN guard or OPA or other types of policy as code directives here to enforce standards to make sure that we aren't introducing misconfiguration risk into our environment through our own customizations, right? And fail that if it doesn't meet those things. This is where step functions comes into play too. Once we've passed all those things and decided this is a good configuration to apply, step functions allows us to orchestrate that complex logic, branching logic. What step am I taking next? What state transition? Do I need to pass some state from that to the next step, right? And what happens if it fails? Managing all that is its job. And then once we've gone through that, right, and we can decide this create, update, or delete operation might take the form of applying a stack set to a new control tower managed account, or it might take the form of a service control policy, create, update, or delete in organizations, right? And again, this also can apply not only to new lifecycle provisioning, but it can also apply to pre-existing accounts as well, right? So let's go through some benefits here, right? We talked about new and existing accounts. Again, pipeline-based CloudFormation workflow means that we can enforce policy, do static checking and analysis, so we can have a little extra safety and guardrails and controls around the customizations we're applying. We can store those deployment artifacts in version control repositories like GitHub or code commit or S3 if that's what you want to do. You can deploy CloudFormation templates and SCPs, right, in order to not only deploy resources, but also protect those resources and put some controls around them as well. What are some detractors? It doesn't have support for delegation today, which means all of the stuff we looked at, all those boxes, that stuff needs to run in the management account, right? Not ideal. So this is a trade-off you have to evaluate and understand based on your threat model, understand, is this something I'm willing to do? Who's going to need access to these pipelines? And am I willing to give them access to the account that has a lot of privilege? Another one is it supports new accounts through lifecycle event workflow, but it doesn't provision new accounts. So if I'm going to provision a new account, I need to do that through Control Tower or some other mechanism like calling out to AWS organizations. What will happen is that this pipeline will detect that new account after it's provisioned and quite quickly. But it is post-provisioning triggered, right? It's not part of the pipeline that says I'm going to use a GitOps model to actually provision my accounts or define those provisionings. And this is where AFT comes in. Let's assume that you're using Terraform. Everybody raise their hands, and this is common, right? We see most of our customers, in fact, are using Terraform in some way, shape, or form, and maybe together with CloudFormation or only Terraform. But one of the big differences here is AFT is both an account provisioning pipeline and a customization pipeline. So that means I get to, when I want to go provision a new account, I get to use a code or GitOps model to say, give me a new account, here's the metadata for that account, push that into Git, and then the Terraform pipeline will immediately start the provisioning of that account and apply customizations to it, right? So if we look at this, one of the first things you'll notice is that this box here is AFT management account, not the control tower management account. It does support delegation, so now I can delegate the pipeline components to run in their own dedicated account that is not the control tower managed account, allowing me to move that away from that high-risk, highly privileged account and really sort of protect and give people access to the pipeline without sort of giving them access to overly privileged accounts, right? Again, code commit, this is our account request pipeline. This could also be GitHub or other connections through CodeStar connections. And our pipeline-based model, again, this opportunity to apply static checkers, linters, formatters like TF lint, or apply OPA policies, CloudFormation guard policies. You can use those against Terraform just as well as CloudFormation, right? Because again, it's just structured JSON. So we can apply policy as code to Terraform in the same way. We do have stateful capabilities here with Amazon DynamoDB. So we have a authoritative store of account metadata, who owns it, what metadata state is in, what version of baselines was it applied, that sort of thing. And we have the ability here to manage both a update to this account. We can adopt existing accounts. You don't have to only use AFT for accounts that you created through AFT. We can take a pre-existing account, define a file in Terraform's AFT's request pipeline to match those metadata details for that account, and it'll figure that out for you and adopt that account for you as well, right? So we can do a CT update, which is going to sort of take us through the account request processing. Or if it's not a CT update, ergo we're not adopting an account or making a change to a pre-existing account already, we will provision an account, right? And if we're doing account provisioning and account vending, right, it has the ability to call back out to Control Tower's management account, initiate that account request through Account Factory Service Catalog, right? Vend us an account and wait for that call back to say that that vending has been complete, and then take back over the process of taking a step functions approach to orchestrating provisioning and customizations, right? At that point, then we'll trigger new pipelines to apply customizations. And this is where AFT brings other capabilities to bear as well. So I'm just going to step through these a little bit here. We can apply global customizations. We can apply individual account customizations. Those could be Terraform based. So global might mean there's something I always want uniformly across all my accounts, no matter what. There's no need to worry about what type of account it is. Just apply these things universally to every account you provision. Individually, you might target individual customizations to types of accounts, groups of accounts. Again, based on different factors like is it prod, is it not prod, is it critical data or not, right? What's the threat model of that account? But the great thing is those are Terraform, but they can also be not Terraform, right? You have the ability inside AFT to run things like Python scripts, Bash scripts. You could run an ECS or Fargate task. You could run a Lambda function. So if there are things that don't fit neatly into Terraform, maybe you want to do some prereq work first and then apply Terraform to that account, right? You can do those things through AFT and define those types of customizations. And you can take this as far as you want. You can build your own orchestrated step functions to sort of apply configurations before Terraform customizations are applied. So it's a very powerful set of capabilities. It's infinitely customizable. Let's see. So again, keeping in the theme here, benefits versus sort of trade-offs, right? This is going to allow us to customize new and existing accounts through a pipeline-based workflow, meaning, again, too, we can provision and customize our accounts all in one place. We have one single place to go. It's authoritative, and we get to keep state and version-controlled history of all of our account metadata, who made changes, and that sort of thing. Artifacts, just like before, can be stored in version control repositories. This does support both published modules, so things like from the Terraform registry. If you want to pull a public module down, you can do that. Or you can have your own custom modules that you've built yourself internally. Doesn't matter. It supports delegated administration, allowing us to reduce that privilege risk there of running in the management account. But what are the detractors? There are a ton of moving parts in there. I mentioned a huge bunch of services that you can take, like ECS and Fargate and Lambda, Python scripts, Bash scripts. There's Terraform, there's GitHub repos. A lot of that stuff runs in your account, right? In this delegated admin account. And it's a lot of moving parts to keep an eye on, to manage, to do version updates as they become available, right? And to make sure they're working. That brings operational complexity, that brings management overhead, and things that you need to worry about, right? And so I think with that, what I want to do is bring Sid back up. He's going to talk to you guys about how we're thinking about reducing that complexity, that management overhead. If we look at what we're doing in the service to bring you a more native approach with account factory customizations, I think you'll see that our direction that we're heading is to try to reduce that last trade-off of CfCT and AFT with something that's a little more service managed and take that undifferentiated heavy lifting from you guys. So with that, Sid, there you are.
Thank you. I know we are more than halfway into the talk, and we haven't talked about the new feature. But hang on, you're just 3 slides away. We'll get there. As Eric said, like AFT is very powerful and customizable, but there are 2 drawbacks to doing all of that work in your account. Number 1 is that you have the burden of managing it and updating it as best practices and your businesses evolve. And number 2, even if you have enterprise support or premium support with AWS, the service teams have limited visibility into what's happening, especially if you have customized AFT from the solution that we have provided. So we heard that in our customer feedback a lot, and that's why AFC was born and announced in reInvent 2022. Now, AFC is a fully managed offering. It's a feature of AWS Control Tower, and so it integrates right into the Control Tower console. So with AFC, when you are in Control Tower provisioning a new account or enrolling an existing account, AFC fits right in, and you can apply the customizations right then and there. And there is no pipelines to build. There is nothing to maintain in your accounts. So let's look at how this works. The first thing I'll say about AFC is that under the hood, it uses a service called AWS Service Catalog. How many here have heard of Service Catalog? Oh, great. OK, about half of you. So as you may know, Service Catalog is a service that's meant for cataloging and sharing and provisioning infrastructure as code templates. Now, Account Factory customization essentially uses blueprints, which are essentially infrastructure as code templates. And then Service Catalog offered a lot of benefits to us, such as being able to version them, being able to organize them into portfolios, or even connect to a GitHub repo where Service Catalog syncs with the repository. And as you merge pull requests, the blueprint keeps updating itself. Right? So there was these powerful features that we wanted to leverage rather than build all over again in Control Tower. So that's why you'll see that AFC uses Service Catalog under the hood. Now, the best practice that we recommend is to have a separate account where you upload your blueprints. This is because you don't want too many team members or too many actions to be occurring in your Control Tower management account, which is a highly privileged account, right? So that's why the best practice is use a separate account for the Service Catalog piece. Then you need an IAM role that allows Control Tower to look in that account for the blueprints. But this is all just one-time setup. Now, once you have this account set up, the next step is to bring your blueprints. These could be IAC templates you already have. You could build new ones, or we also offer AWS partner blueprints from partners like Cisco, Datadog, Splunk, and more. Once you have those blueprints, you put them in a Service Catalog portfolio, which is essentially a grouping mechanism for blueprints. With these 3 steps, your work in Service Catalog is done. And so now you're ready to start creating and customizing accounts in Control Tower. So now you come back into the Control Tower console, and you're either enrolling a new account or building a new account. And then all you do is a simple operation to select the Service Catalog account and the blueprint you want to apply. And that's it. Now Control Tower takes care of actually building the account, applying the blueprint, and when the account is provisioned, it's fully ready for business and fully customized based on that blueprint that you provided. So this is how AFC takes the complexity away from you and makes it just a few simple clicks to get a customized account. So let's quickly recap some of the benefits and drawbacks of AFC. As I mentioned, it's a fully managed feature of Control Tower, so there's very little burden on you, the customer. You can, again, just like CfCT, you can use it for either creating new customized accounts or when you're enrolling existing accounts into Control Tower, or if there are already existing accounts in Control Tower, but you now want to apply new customizations. All 3 of those are possible with AFC. Third is you have access to these partner blueprints that I mentioned. We launched in reInvent with 11 partners, but this number keeps growing, and you get the benefit of this. And this is especially key because customers told us that it's relatively easy to have your own infrastructure as code templates applied to your own accounts, but it gets harder when you want to integrate a third-party SaaS solution with your accounts. And so AFC makes it super easy for you. Now, what are some of the drawbacks? The first drawbacks is we don't have APIs yet. It's only in the console. This is something we hear all the time, and we are working on it. It's on our roadmap for this year, but there's no APIs yet. And the second is currently you can only use one blueprint per account. Again, this is feedback that we are hearing from customers, and we are working on to let you compose multiple blueprints in different combinations based on the type of account, like a prod account or a shared services account and so on. So that's account factory customization. With that, I'm really excited to share a new feature with you today, which is account factory customization support for Terraform. I see some people clapping and cheering, which is great. So before this launch, you could only use CloudFormation templates as blueprints for AFC. But now, you can also bring your Terraform HCL configurations as blueprints and apply them with the same simple experience that you had with CloudFormation. Now, remember I mentioned before of why we use Service Catalog under the hood so that we can take benefit of all of its features. Now, Service Catalog launched Terraform Support in April, and AFC was able to benefit from it and quickly surface it to our customers to be able to use Terraform-based blueprints. And the best part is that your experience in the Control Tower console is exactly identical for Terraform and CloudFormation, as Eric will soon show in a demo. So let's walk through the steps. Step number 1 is to bring your Terraform files, and you create a single archive of them, and that becomes your Terraform blueprint, right? So that's how you define your blueprint with all your HCL configuration. Step number 2 is you need to set up a Terraform engine that actually runs the plan and apply commands. And this engine lives in the same account as the service catalog. Now, this is a one-time setup that you have to do even if you're going to provision hundreds or thousands of accounts later. And there's only one instance of the engine that you need in the hub account. AFC continues to use that engine for any number of accounts that you provision. Now, we recognize that this can be a little hard work to provision all of the right pieces of the engine and connect them to service catalog. So we have a reference engine for you on GitHub, and it has a bash script that in a single script will set up all of the required components for you. So I would encourage you to snap that QR code and get started with that engine setup. Now, once you have run that script and the engine is ready, you're all set. Now, in the Control Tower console, you would basically just select the service catalog account, select your Terraform blueprint, and click Create Account. The account will be created in Control Tower, and the Terraform customizations are applied right in the same flow. Let's see a demo of that with Eric.
Thanks, Sid. So before we get in too far, let's just set a little bit of stage here for what we were talking about. As Sid mentioned, right, the idea here is that with AFC, you don't have to have a bunch of moving parts for orchestration. And all you guys have to do is worry about the environment and the configuration changes that you want to make to that environment, and we'll handle the rest. Now, the execution of that doesn't matter what language you're going to use. If it's CloudFormation, this setup will look the exact same as Terraform, with a few exceptions that we need to run some reference engine stuff. But over the fullness of time, what we really want to do is increase that capability set for you guys, reduce any additional benefit or overhead there that's left to you, and really think about the ability to apply customizations at scale. And so we're looking at a lot of exciting new things in here, but this is the first step for us. And really, as we look back here, harkening back to Sid's Control Tower architecture, we have Account Factory, right, which is that traditionally create an account sort of mode, and that's where things stopped. Now we have this concept of blueprints as a first-class principle, which is essentially that customization. What should be applied to the account during provisioning so that when you get the account, it's actually ready for you to use based on how you've defined it, right? So if we look at this process now, what we're going to do in our demo is sort of provision an account through Control Tower and the sandbox account. And let's imagine, this is a contrived example, but let's imagine that we have a need to establish some S3 bucket centrally on all of our accounts for our security engineering team to use for log ingestion and then things like that. As Sid mentioned, we can have delegated accounts where we can move all of the service catalog management stuff. This is where we're going to define new versions of our blueprints, where all of that stuff's going to live. That can be out of the management account so that we can give people access to that without giving them access to the Control Tower management account. And what's going to happen here is step number one, we're going to create this empty AWS account and enroll it into Control Tower like normal. And then after that, access the blueprint that we've defined in the Service Catalog Hub account in this case, right? And it doesn't matter whether it's CloudFormation or Terraform, it will figure it out and do the right thing based on that, right? And then step three is that Service Catalog will take that blueprint, create a copy of it as a provisioned portfolio, share it out to your target provisioned account here through Service Catalog's native capabilities, and create that local portfolio. Step number four, we do a call back into the hub account to apply that Terraform, right? And this is where we get to have things like we have an SQS intake queue to manage this. We have Lambdas that can sort of process all that in there for you and do checks and things like that, and then do a Terraform apply against that account for you. And the great thing here is that if, from a scaling perspective and a dependency inversion kind of model, right, is that if we're provisioning large amounts of accounts, we have callbacks into this SQS fan-out queue, right? And we can have one place with one copy of Terraform engines running to sort of handle all that provisioning work, but it's only one, no matter how many we're scaling out to. It can thread out, fan out, and handle that scale for you. And then step number five is that blueprint, that Terraform apply in this case, is going to execute, and those resources that we defined in our blueprint are going to be provisioned in the new account. And Terraform or AFC will manage that apply execution for you and wait until everything's been successful and verified as successful, store that persistent state for you in the back end, and then call back to Control Tower to let us know that that blueprint has been successfully applied and give us a bunch of metadata details, which we'll see in our demonstration here. So first, we can just look a little bit at some Terraform here real quick. In this demo, we are breaking up our Terraform definition into multiple files. Here we have our provider that's just letting us know that we're using the HashiCorp AWS provider, pinning to some versions, and setting up our region as per best practice here. And we've got a main TF file in this case, which is defining our S3 bucket. And we're setting up things like bucket versioning, blocking public access as an enforced setting, and we're setting up server-side default encryption and bucket keys on the bucket. And in this case, we're also setting up a bucket policy on the account that does a few things. It sets up a secure cross-account access to that bucket from our security operations, our SecOps account. And sets a condition that says principal org ID, right? So if that SecOps account, for some weird reason ever down the road, leaves our organization, we want to say, well, that's not okay, and it should lose that access, right? So we restrict that access to SecOps as long as it's part of our org. And then it denies any S3 operation if it's not using SSL transport. And then we provide some outputs, right? So we have the ability, just like any other normal Terraform, to pass input variables, output variables, that sort of thing. And we define some variables here, just like normal Terraform stuff, right? Where we're asking for a bucket name, setting some descriptions. We might put some validation and some constraints on those, right? Like maybe we'll put some regex patterns in here to enforce some input constraints and sanitize those inputs. We can have defaults in here. And the great thing here is that when the Terraform reference engine loads all of your blueprint here, it will evaluate all of these variables, the constraints that are attached to them, and make sure that those are being enforced as well, and present those to you in the console or the user experience so that you're able to understand what are my input variables for this blueprint, what are the constraints for it, so at runtime you know how to fill them out if you need to. And just, for sake of consistency, we also have the exact same thing in a CloudFormation template, right? So this is going to net the same exact result. So in this case, we could have a CloudFormation template and a Terraform module that do the exact same thing for us, and we're going to put those down into a service catalog policy. So if I go into here, we're in our hub account, which we were talking about before, and I'm in Service Catalogs console. If I come look here at Control Tower blueprints, we can see that I've got a portfolio set up. Again, as Sid mentioned, we're just sort of grouping baselines or blueprints and templates together into a group. We've got some metadata in here, and we've also got both our CloudFormation version of this bucket and our Terraform version of this bucket, right? And if we come in here and look at this, we can see that the product type now is Terraform open source. That's dynamically determined by Service Catalog. And we've got some details in here. You can see we can support multiple semantic versions of this. So as this changes over time, we can increase the versions and deploy those. And we're able to see in Control Tower what version of the blueprint has been applied to our accounts and make sure that we're consistently updating them over time so that we don't have any drift. And if we go look at one of these, like latest versions here, we can see there's like a link to our template archive artifact if we want to go pull a copy of that, and any provisioning parameters that it determined and evaluated here, right? So it's already parsed those things. So if we go back in here and to our management account, oops. And we go into Control Tower's view. As Sid mentioned, when I go to organization, now I'm going to see some things that I didn't see before, which is this concept here of blueprint name, right? Here you can see that this account has the core engineering team S3 bucket blueprint applied from our service catalog hub account, and that the blueprint status is active and what version has been applied to it, right? And at any time, if I want to go make changes to this or say do a version bump on this, I can just come in here and execute an update account on this and apply this new version to the account, and AFC will go off and take care of that for me, right? And what's great is that if I come back in here and I want to say create an account, before, like we mentioned, you had to sort of do this in two different places in a lot of cases. But what we have now is one consistent experience here. So if I come in here and set up a new account, I'm just going to call it ML Training Dev or something, if I can type. Right. I get to pick my OU. Where should we deploy this? Let's put this like in non-prod. And I now have this AFC or account factory customizations right here during my account provisioning. I tell it what account is my delegated admin account for Service Catalog Hub, right? And I can hit validate account. And this will go make sure that Control Tower has all the privileges it needs to get into that account and see blueprints. And now I'm presented with, I could do CloudFormation, I could do Terraform. Again, same output at the end, but doesn't matter. There's no distinct user experience change based on whether I'm using Terraform or CloudFormation. I'll pick Terraform here, give it a product version of 101, and now I'm presented with my parameters that are in that Terraform module, right? And so in this case, I'm just going to give it a bucket name and leave the defaults as they are, and select my region and create account. So now, instead of all of the other things I had to do back in CfCT or AFT, I had to go write a bunch of manifest files, map account metadata to what customization should be applied. Right here, when I created the account, I was able to tell it what I wanted, here's the metadata, and here's what good looks like from a blueprint or baseline perspective for this account, right? And then over time, this is going to go create that account, do all of its normal Control Tower stuff, right? Create the account, set up controls, enroll it for governance under Control Tower, and apply that blueprint for us. And then when all that's done, we'll get our lifecycle emit that says everything's been successful, this account's ready to vend to your end users, and we're off to the races. So rather than sit here and wait for a new account to create for 15 minutes or whatever, we'll just go take a look at one of these that we've already done. So this sandbox one here has already had a Terraform module applied to it to do what we just asked Control Tower to do for our new account. And we can go into Service Catalog and our target account and see that we have a Control Tower managed blueprint that's been put in here by Control Tower without us having to do anything. This was shared out from that hub account automatically using Service Catalog. We can see it's a Terraform blueprint. We can see all the details here. We can also look at the constraint, and this is a launch constraint that is enforced by the Terraform and AFC component here, which is essentially what permissions does it need, right? And so this is going to create, like we mentioned before with CloudFormation StackSets, when we're applying that, it's going to set a IAM role that's least privilege in there and allow you to, you can also scope this down when you're executing that, right? So it's a very good way for us to scope down those privileges to least privilege and make sure that we're proceeding successfully. And lastly, if we go look at the S3 bucket, it is, of course, here, right? And so there is our Terraform blueprint. So back to Sid to wrap us up. There you are.
Thank you. We are super excited about this feature launch and can't wait for you guys to try it and then give us feedback of how we can do even better. So with this, before we wrap up, I think it's a $1 million question of, hey, you've introduced 3 different frameworks, but which is the right one for me to use? And if you have followed through the talk, there isn't one size fits all answer, right? Based on your use case, based on your scale, and whether you want to run it through a pipeline or you prefer a more single UX model, you can choose the right framework that meets your needs. So going back to the customers we spoke about for these 3 companies, you can imagine that company A, with its basic customization need, could easily do it with AFC without having to have the burden of pipelines. Company B could use CfCT, and then company C, who prefers Terraform, could use AFT, or now with this feature launch, could also use AFC with Terraform. There are 2 things I want to emphasize here. It's OK, we are almost done. There's 2 things I want to emphasize here. Number 1 is this is not an either-or choice. You can absolutely combine multiple frameworks together. So we have customers who use AFC to deploy a set of IAM roles in each of their provisioned accounts, and then do CfCT to provision some specific services in each of those accounts. So you can combine them. And second, as we go through time, like each of these keep getting new functionality and features. So when it's time for you to use a framework, I would encourage you to look at AFC, see what features it supports, and then make your decision. Along with these, there are some more additional options we have as well. AWS organizations has their own integrations with services like guard duty, config, and others. So customers use those along with Control Tower. We also have solutions that our partners have on AWS Marketplace that integrate with Control Tower and help you customize those accounts with those third-party offerings. And then we have Landing Zone Accelerator, which is a very specialized solution that if you have very sensitive or highly regulated workloads and you're trying to hit multiple compliance frameworks, you might want to look at Landing Zone Accelerator. So these are just some more options other than the 3 we already talked about. As my last slide, I wanted to leave you with how we as AWS Control Tower are thinking about the future. So both AFT and CfCT solutions are now supported by our service team, and we will continue to support them going into the future. But from our point of view, AFC is really our North Star and the place we want to focus most, because it again gives you the benefits of customization while taking the heavy lifting out of your accounts into the service account, right? So that's why AFC is our North Star going forward. With that, I want to thank you for your time and attention. It's been great sharing these with you. Please take a minute to fill the survey and have a great rest of Reinforce. Thank you.